All right. So I had somebody ask me about a nasty looking log problem, and I'll show you. I'll show you what it looks like and see if we can make sense out of this thing. So we are given something weird. We are given that this whole sequence, natural log of x plus natural log of x squared plus natural log of x cubed, all the way up to the k's power. Somehow this all equals 2k times k plus 1. And we are asked to show that x equals e to the fourth. And that, I don't know, that seems weird. So let's just give it a shot. So there's two things that I know here. I know that if you have a power, you can move it in front of a logarithm. And I know that if you have the sum of different logarithms, you can multiply them. So let's just try multiplying. Um, so these first two pieces would become, yeah, I guess it doesn't matter what order you go in. These first two pieces would become natural log of x cubed. And then we've got all the rest of it up there. So there must be some sort of shortcut. If I added in the next piece, it'd be natural log of x to the sixth, plus all the way up there. What I'm noticing is that as I add in each piece, the next one would be adding in the next piece that's in the dot, 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 so x to the fourth, right? So then I'd have natural log of x to the 10th, plus all the way up there. What I'm noticing is that the uh, the power that I'm getting here is the sum of the first n natural numbers. So like this right here is 1 plus 2. This is 1 plus 2 plus 3. This is 1 plus 2 plus 3 plus 4. So after I combine all those terms, it's going to be the natural log of x to the sum of the first, we add it all the way up through k. So it's going to be the sum from n equals 1 to k of n. Okay. And then what I know is that we can move that, because the log property says that you can move the power in front of the logarithm. So I know that what we have is the sum of the first k numbers times the natural log of x. And I know that that has to equal this 2k times k plus 1. Okay, so maybe a little sidebar problem here. Uh, if you remember adding up the sum of the first k numbers, the way you can do this is you say you got 1 plus 2 plus 3 all the way up through plus k, and you can actually reverse it, k plus k minus 1 plus k minus 2 dot 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 plus 1. And what you notice is that if you add term by term, you end up with n copies of k plus 1. Sorry, not n copies, k copies of k plus 1, because that's how many terms you have is k copies. But the trick that I did there was I wrote the same sequence twice, so I doubled it. So the answer I just wrote, k times k plus 1, is actually twice as big. So we divide it by 2. So this piece right here is equal to the sum that I wrote in front of it. When I wrote it down here on the bottom, I forgot the letter n. What I'm noticing is that if you add up the first n natural numbers, it's going to become this. So this is the sum from n equals 1 to k of n. So I can pop that right in there. So now I know that this is really equal to, let me erase a little bit here. Okay, so what this is really equal to is k times k plus 1 over 2 times the natural log of x. And we were told at the very beginning of this problem that that expression needed to equal 2k times k plus 1. And I'm going to solve for x. So divide both sides by k, divide both sides by k plus 1. And where we end up with is just natural log of x divided by 2 equals 2. So I'm going to clear the screen and just finish out with that. Natural log of x divided by 2 equals 2. Multiply by 2. Exponentiate both sides. So x has to equal e to the fourth. So the thing that you had to do for this problem was use some properties of logarithms, and then recognize that you have the sum of the first n natural numbers. It's an arithmetic series, so you could have used the arithmetic series formula. I just showed you in a little side problem the arithmetic series formula if they're all just natural numbers, and then you set it equal to the thing and solve for x as e to the fourth. So let me know if you've got any questions, and I'm happy to help out.